Hi guys, welcome to my channel Pint. Today I will be showing you the basic limits of calculus. So let's get started. First, what is a limit? A limit basically tells us how a function will behave when it is approaching a certain value. So let's take the function f of x, the letter x, the letter c, and the letter l, where f of x is an equation, x is a number, c is the number that x is approaching to, and l is the final limit. And with these letters, let's create a basic equation for a limit. So let's take the limit of an equation f of x as the letter x is approaching to some value of c, which will result in l. And let us take the limit of, let's say, an equation of 2x, where x is approaching to some value of c, which, let's say, 2. And that will give us the result of the number 4. So what do? We basically take the number 2 and we plug that 2 into the letter x of the equation 2x, and that should give us the answer of 4, because 2 times 2 is 4, and so the limit of the equation 2x is basically 4. And here are some basic limit laws, where it's basically saying if you have two equations that are being added, subtracted, multiplied, or divided from each other, if you find the limit of each equation, you can add them, subtract them, multiply them, or divide them from each other. And with the constant rule, if you have an equation that is being multiplied by a constant, you can just take that constant out and then find the limit of that equation, bring the constant back in, and then multiply that constant with the value that you got for that equation's limit. And with the power rule, you can basically find the limit of that equation and then raise it to the nth term for the answer. And then with the root rule, you can basically just do the same and find the limit of that equation and then take the nth root of that limit and it will give you the answer. And that's basically the limit laws. As for the commonly used limits, these only apply to limits as x is going to positive or negative infinity. As you can see in number 1, the limit of the equation ln over n as x is approaching to infinity is equal to 0. The limit of x to the 1/nth as x is approaching to infinity is equal to 1. The limit of x to the nth power as x is approaching to infinity is equal to 0. The limit of 1 plus x over n raised to the nth power is e to the x, and the limit of the nth root of n as x is approaching to infinity is 1. And these limits, you do not have to prove them or anything because they're part of the commonly used limits. So if you ever see these limits on anything, you can basically memorize it and get them right away. So let's do some examples. For example 1, as the limit of x squared minus 1 over x minus 1 as x goes to 1, you can plug in 1 for x, as you can see, and it will give you 0 over 0. But we can't divide 0 over 0, so we must factor this equation. So x squared minus 1 can be easily factored into x minus 1 times x plus 1. So then we write it again. So the limit as x goes to 1 of x minus 1 times x plus 1 over x minus 1. And you can cancel out x minus 1 in the numerator and the denominator, and that will give you, again, the limit as x goes to 1 of x plus 1 you can take the number 1 and replace it in x, and then it will give you the limit as x goes to 1. So 1 plus 1 will give you 2. So let's start in example 2. So you take the limit as x goes to 2 of x squared plus 4x plus 5, where we can take the value 2 and we can simply just plug it into all of the x's. And it will give us the limit of x going to 2 of 2 squared plus 4 times 2 plus 5. And you can simplify that, and it should give you 4 plus 8 plus 5. It should give you 17. And this is the rational rules, where basically if you have a rational function in your numerator and in your denominator, if you look at the highest powers of the numerator and the denominator, 1, if your two powers are equal to each other, you can take the coefficient and find the limit. 2, if the numerator's power is less than the denominator's power, then the limit of that rational function is automatically 0. And then 3, if the numerator's power is bigger than the denominator's power, then you can divide the two functions to find the limit. So let's do some examples with the rational rules. So for number 1, for the limit as x goes to infinity of 5x to the 10th plus 4x to the 6th plus 7 over 2x to the 10th plus 4x plus 2. Since the power in the numerator and denominator are the same, we can take the ratio of 5 over 2, and that is the limit, and that is also the answer. Let's do number 2 now. So for the limit as x goes to infinity of the square root of x plus 2 over x plus 1, we can take the square root of x and turn it into x to the 1/2 over x to the 1. Since 1/2 is less than 1, the answer is 0. As for number 3, we take the limit as x approaches to infinity of x cubed plus 3 over x squared. And since the numerator's power is bigger than the denominator, you can divide it. And so I'm going to divide and split x cubed plus x3 into two equations. So this will become 3 over x squared, and x cubed divided by x squared is simply x. And now I will take the limit of x plus 3 over x squared. And since 3 over infinity squared is 0, it'll turn into x plus 0. So you plug in infinity for x, and infinity plus 0 is infinity. And this concludes my lesson on the basic limits of calculus. Hope you enjoyed.